Welcome to our deep dive today. We're going to unpack the life and work of the incredible James Clerk Maxwell.
Incredibles, right?
Our main source is this insightful biography by Lewis Campbell. And you know what I found really fascinating? Maxwell was so much more than just formulas and equations.
Oh, yeah, absolutely.
He had this playful curiosity and deep faith that really shaped his whole scientific journey.
It's true. It's easy to just focus on the achievements, the scientific achievements. But understanding Maxwell as a person, it really adds a whole new dimension to his work.
Absolutely. So to kick things off, let's rewind all the way back to Maxwell's childhood.
Okay.
Rural Galloway.
Right.
Imagine growing up surrounded by places with names like Torholm and
Knockvenny.
Knockvenny. Yes.
Yeah.
It's like a landscape straight out of a storybook.
It's a very unique environment. And it seems like it really nurtured his sense of wonder.
Yeah.
And his love of nature from a very early age. In Campbell's biography, there's this great anecdote. Oh.
About Maxwell's father,
Okay.
who always encouraged his son's natural curiosity. He wasn't a scientist himself.
Right.
But he had this persistent thoughtfulness.
I love that. Persistent thoughtfulness.
And problem-solving approach that just rubbed off on young James.
It's like the perfect description.
Right.
Of a budding scientist's mind always churning.
Exactly. And there's this story about Maxwell as a child building these complex geometric shapes
Okay.
before he even learned the formal definitions in Euclid.
Wait, hold on. He was constructing polyhedra before even knowing what they were called.
It suggests this innate understanding of spatial relationships, and almost like he intuitively grasped these complex concepts.
So that's incredible. And it wasn't just geometry. Even as a young boy, Maxwell was experimenting with things like electrotyping
Oh, wow.
to create beetle seals.
Which is not your typical childhood hobby.
Definitely not your average kid. This brings us to his time at Edinburgh Academy, where his unconventional attire...
Think Gallivitian clasps and square-toed shoes
Wow.
made him stand out, to say the least.
It's almost as if he was challenging social norms, even unintentionally.
Yeah.
And it's interesting to think about how those experiences might have reinforced his intellectual independence and resilience. It takes a certain kind of confidence to stand apart, especially in a rigid academic environment.
Absolutely.
Yeah.
But thankfully, his talent didn't go unnoticed. Professor Forbes, a key figure at the Academy, was really impressed by Maxwell's early work. In fact, there's this incident described in the biography. Forbes becomes aware of Maxwell's talent through a paper he'd written on oval curves.
Oh, interesting.
Can you tell us a bit more about that?
Yes, so this was a pivotal moment for young Maxwell. He was only a teenager at the time.
Wow.
And Forbes recognized the brilliance of his work. It dealt with the properties of these oval shapes, which we would now call ellipses, and how they could be generated through specific geometrical constructions. Forbes was so impressed that he presented Maxwell's findings to the Royal Society.
Wow.
A prestigious scientific institution.
A Royal Society.
Yeah.
That's a pretty big deal for a teenager. It must have been very encouraging to have that kind of recognition so early on.
It was, and Forbes went on to become a crucial mentor for Maxwell, recognizing his potential and encouraging his scientific pursuits. You can even sense Forbes's excitement in a letter he wrote to Maxwell's father, praising James's ingenuity and the novelty of his work, despite his young age.
It sounds like Forbes played a vital role in nurturing his talents. What happened next in his educational journey?
Well, despite some early struggles fitting in socially, Maxwell eventually found his tribe at Cambridge University. He formed close bonds with other brilliant minds, like Peter Guthrie Tate and John Leslie Porter, and their intellectual camaraderie really fueled his growth.
That makes sense. It's like having a group of friends who are equally passionate about learning and exploring new ideas.
Exactly. These friendships provided a space for bouncing ideas, challenging assumptions, and pushing the boundaries of knowledge together. And you can see in their letters how they sparked each other's curiosity and encouraged each other to tackle complex problems.
It's amazing how those connections can shape a person's trajectory. And from what I've read, Maxwell wasn't just interested in one specific area. He was diving into everything from optics and color to fluid motion. And of course, what he's most famous for, electromagnetism.
That's right. And if we connect this to the bigger picture, you start to see how all of these seemingly disparate fields ultimately fed into his revolutionary work on electromagnetic theory.
So his wide-ranging interests actually became a strength.
Absolutely. It's a testament to the power of interdisciplinary thinking. By exploring different fields, Maxwell was able to bring fresh perspectives and insights to his work on electromagnetism, leading to some truly groundbreaking discoveries.
That's so cool. And speaking of fresh perspectives, his letters from this time are filled with these vivid descriptions and anecdotes
Yeah.
that give you a real sense of his personality. For example, he talks about building a cubicle box water prism to observe Fraunhofer lines, which, for our listener, are these dark lines in the spectrum of sunlight caused by the absorption of light by elements in the sun's atmosphere.
He had this amazing ability to explain complex scientific ideas
Yeah.
in a way that was both engaging and understandable.
Yes. And there's this other great story where a pipe bursts during one of his lectures. And he uses the incident to explain water velocity to his students. Talk about turning a chaotic situation into a learning opportunity. He clearly wasn't afraid to be creative and find inspiration in the everyday.
It shows his passion for teaching and his knack for finding those teachable moments, even in unexpected places. He understood that true understanding comes from connecting theoretical concepts to real-world phenomena.
And then there's this work on Saturn's rings. He took this existing mystery. At the time, people thought the rings might be solid.
Right.
And he completely revolutionized our understanding of them.
What's fascinating here is how he did it. Maxwell combined mathematical analysis with physical intuition and a touch of creativity. He even built a physical model to demonstrate the concept of a ring composed of countless small particles, each orbiting Saturn independently. Through this, he was able to disprove the theory of solid rings, showing that they would be unstable and would quickly break apart under the gravitational forces of Saturn and its moons.
It's incredible how he was able to visualize and conceptualize something so complex, something so far away.
It is. And his use of models and analogies was key to communicating his ideas and making them accessible to others. In fact, his model of Saturn's rings, with those countless particles and the waves that would exist within them, turned out to be remarkably accurate when compared to later observations from spacecraft.
That blows my mind. To figure out the structure of something millions of miles away without ever actually going there, that's the power of scientific thinking, wouldn't you say?
Absolutely. And his work on Saturn's rings is just one example of his wide-ranging scientific curiosity. He also made significant contributions to our understanding of color perception, creating a color diagram that showed how all the colors in the spectrum could be derived from a mix of 3 primary colors.
Oh, yes, I remember reading about that.
Yeah.
And his work with color perception had a huge impact on fields beyond just science, right?
Definitely. It laid the groundwork for modern color theory, which has had a significant impact on fields like photography, printing, and even our understanding of how the human eye perceives color. His work is another example of how his seemingly theoretical pursuits had very real and practical applications.
This making me see physics in a whole new light. It's not just about abstract equations. It's about understanding the world around us, from the colors we see to the distant planets we observe. And what's even more remarkable is that Maxwell's scientific pursuits were deeply intertwined with his religious faith.
It's a fascinating aspect of his life that challenges the stereotype of the skeptical scientist. Maxwell saw no conflict between his scientific work and his belief in God. In fact, he saw the study of nature as a way to deepen his faith, revealing the intricate order and beauty of creation.
And he wasn't shy about expressing those views. He wrote extensively in his letters about his interpretations of Scripture, and even delved into the works of philosophers like Kant and Mill, searching for a framework that could reconcile his scientific understanding with his spiritual beliefs.
He was a complex and multifaceted individual, constantly seeking knowledge and meaning, and never settling for simple answers. This intellectual and spiritual curiosity is even more evident in the 2 unfinished essays found in his notes, titled Sensation and Reason and Faith. It's as if he was grappling with the fundamental questions of existence, trying to understand the nature of reality itself.
It makes you wonder what those essays would reveal.
It does. They offer a glimpse into a mind that was constantly exploring, constantly seeking deeper truths.
This brings us to a pivotal point in Maxwell's life: his move to Aberdeen, to head the natural philosophy department at Marischal College.
It's a significant transition for him, marking a shift towards a more prominent teaching role and a deeper commitment to shaping the next generation of scientists.
And based on what we've read, he was an extraordinary teacher. He wasn't content with simply lecturing. He believed in hands-on learning and used creative methods to make complex topics accessible to his students.
Absolutely. He was a proponent of experimental demonstrations, using things like bullets to represent an undulatory medium.
Bullets.
Yeah, basically a medium through which waves can travel, or recreating complex experiments for his students to witness firsthand.
Wait, bullets to represent waves. I never would have thought of that. It speaks to his incredible ability to think outside the box
Exactly.
and find those unexpected ways to illustrate complex concepts.
And beyond the demonstrations, his teaching philosophy really comes through in his letters. He talks about the importance of adapting to the needs of his students, blending practical applications with theoretical knowledge to make sure they truly grasped the material.
It sounds like he was way ahead of his time in terms of educational pedagogy.
He was. And this commitment to clear explanation is also evident in his choice of textbooks. He favored texts that focused on practical applications and avoided unnecessary complexity, which aligns perfectly with his own teaching style.
It's like he had this deep-seated belief that knowledge should be shared, and that everyone, regardless of their background, could grasp these scientific concepts if they were explained in the right way.
I think you're right. He saw teaching as more than just conveying information. It was about empowering his students to think critically and to apply their knowledge to solve real-world problems.
And amid all this teaching and research, there's another big development in Maxwell's life. He gets married. He ties the knot with Catherine DeWar. And it seems from his letters that their relationship had a profound impact on both his personal and professional life.
Their partnership was truly remarkable. Catherine was much more than just his wife. She was a true intellectual companion, often assisting him with experiments and even editing his manuscripts.
They were a true power couple,
Yeah.
supporting each other's intellectual and personal growth.
Yes, and you get a sense of their deep connection in this beautiful quote from Maxwell about the transfusive tendency. He talks about how much he values genuine connection and the sharing of thoughts and feelings.
It reveals a side of him that we don't often see in the textbooks.
Mm.
A warmth, a generosity of spirit, and a deep appreciation for human connection.
It reminds us that behind those groundbreaking scientific discoveries was a person with a heart full of love, compassion, and a desire to connect with others on a deep and meaningful level.
And that's a great place to pause for now. We've covered a lot of ground.
We have.
From his unconventional childhood to his groundbreaking work on Saturn's rings and color
A
perception.
lot of ground.
Welcome back to our deep dive into the extraordinary life of James Clerk Maxwell. Before the break, we were exploring his captivating journey as a teacher and his multifaceted personality.
Right.
Now, let's shift our focus to the scientific discoveries. That truly solidified his place in the annals of history.
Okay.
This is where Maxwell's genius truly shines. His ability to synthesize information from seemingly unrelated fields,
Yes.
his remarkable mathematical prowess,
Yeah.
and his intuitive grasp of physical concepts all converge to produce groundbreaking insights. That forever changed our understanding of the universe.
It's true.
And his work on electromagnetism is a prime example of that. It's where things get a bit mind-bending,
Yeah.
even for those of us who aren't physicists. But I'm eager to delve into it because it sounds absolutely revolutionary.
It truly was revolutionary. Before Maxwell, electricity and magnetism were studied as separate phenomena. Scientists like Faraday had observed connections between the two, but no one had been able to develop a comprehensive theory to explain how they interacted.
So what was Maxwell's breakthrough?
Well, he took the existing experimental work, particularly the work of Faraday, and combined it with his deep understanding of mathematics to develop a set of equations that describe the behavior of electricity and magnetism in a unified theory.
Okay.
These equations, known as Maxwell's equations, showed that electric and magnetic fields are not independent entities, but are fundamentally intertwined.
So he's basically saying that electricity and magnetism are two sides of the same coin.
Precisely. And even more revolutionary, his equations predicted that these electric and magnetic fields could propagate through space as waves,
Okay.
electromagnetic waves.
And these electromagnetic waves, what are they exactly?
That's where it gets really interesting. Maxwell's calculations showed that these electromagnetic waves traveled at an incredibly high speed, a speed remarkably close to the speed of light, which had already been measured experimentally. This led him to a groundbreaking conclusion that forever changed our understanding of the nature of light.
Wait a minute. Is he suggesting that light itself is an electromagnetic wave?
Yes, that was his revolutionary insight. Light, which we perceive with our eyes, is not some mysterious substance or a separate phenomenon, but a specific type of electromagnetic wave. It's a manifestation of the electromagnetic force, just like electricity and magnetism.
That's an incredible aha moment. It's like suddenly seeing the connections between things you never thought were related.
Exactly. It was a stunning unification of two seemingly disparate fields, optics and electromagnetism, and the implications of this discovery were profound.
So what did this new understanding of light lead to?
Maxwell's work paved the way for a technological revolution. If light is an electromagnetic wave, then other forms of electromagnetic radiation must exist. And indeed, subsequent experiments confirm the existence of radio waves, microwaves, infrared radiation, ultraviolet radiation, X-rays, and gamma rays, all part of the electromagnetic spectrum.
So all these different forms of radiation are essentially variations on the same theme.
Electromagnetic waves.
That's right. And each type of radiation has its own unique properties and applications, from radio and television broadcasting to medical imaging and wireless communication.
Exactly.
Wow, so we can essentially thank Maxwell for our Wi-Fi, our smartphones, even the X-rays we get at the dentist's office.
In a way, yes. His work laid the theoretical foundation for the entire field of electromagnetism, which has had an immeasurable impact on our modern world. It's hard to imagine modern life without the technologies that stemmed from his discoveries.
That's pretty mind-blowing. But I have to admit, thinking about these equations and fields and waves, it's all quite abstract and complex. Did Maxwell's work have any practical applications beyond understanding the nature of light?
Absolutely. His equations are still used today by physicists and engineers to understand and manipulate electromagnetism in countless ways. For example, they're used in the design of electric motors, generators, transformers, antennas, and all sorts of electronic devices.
So his work wasn't just theoretical. It had real-world applications from the very beginning.
That's right. And what's remarkable is that Maxwell's equations have stood the test of time. They are as valid today as they were when he first formulated them in the 19th century.
That's a testament to the power and elegance of his work.
Oh.
But you mentioned earlier that he didn't just stop at electromagnetism, right?
Yep.
What else did he contribute to the world of physics?
His intellectual curiosity knew no bounds. He also made significant contributions to thermodynamics,
Thermodynamics.
the study of heat and energy, and kinetic theory, which seeks to explain the behavior of gases in terms of the motion of their constituent particles.
His work on the kinetic theory of gases really caught my eye while we were going through the source material for this deep dive. Can you elaborate on that a bit?
Certainly. Before Maxwell, the behavior of gases was a bit of a mystery. Scientists knew that gases exerted pressure, and that they expanded when heated. But they didn't have a clear understanding of why.
So how did Maxwell approach this problem?
He applied statistical methods to the study of gases, recognizing that while it's impossible to track the motion of each individual molecule, we can make predictions about the average behavior of a large collection of molecules.
It's like trying to understand the flow of traffic by looking at the movement of individual cars versus looking at the overall traffic pattern.
Exactly. And based on this statistical approach, he developed a probability distribution function, now known as the Maxwell-Boltzmann distribution, which describes the distribution of molecular speeds in a gas at a given temperature.
So he's basically saying that even though things seem random at the molecular level, there are still predictable patterns when you zoom out and look at the big picture.
Precisely. His work provided a deeper understanding of concepts like temperature and pressure, showing how these macroscopic properties emerge from the microscopic behavior of individual molecules.
And this laid the groundwork for statistical mechanics, right? I remember reading that statistical mechanics is a powerful tool for analyzing complex systems, not just gases.
That's right. Maxwell's work was foundational to the development of statistical mechanics, which has applications in fields ranging from physics and chemistry to biology and economics.
It's amazing how he was able to connect those seemingly disparate worlds, the invisible realm of molecules and the observable world of pressure and temperature.
It speaks to his unique ability to see those connections, those underlying principles that govern the universe at all scales.
And let's not forget his work on Saturn's rings. It wasn't just about disproving the solid rings theory. He came up with a whole new model that was remarkably accurate. How did he do that without ever even seeing the rings up close?
It's a testament to the power of scientific reasoning and imagination. Maxwell applied the laws of physics and mechanics to analyze the stability of different ring structures. He realized that a solid ring would be inherently unstable, as any slight perturbation would cause it to collapse under its own gravity.
So he ruled out the solid ring theory based on physics alone.
Yes. He then considered the possibility of a ring composed of multiple smaller bodies, each orbiting Saturn independently. He used mathematical models to analyze the behavior of such a system, and found that it was much more stable than a solid ring.
And to prove his theory, he didn't just rely on equations. He built physical models to simulate the behavior of the rings. He even created a model to demonstrate the concept of waves within the ring, caused by the gravitational interactions between the particles.
That's right. His approach highlights a key aspect of scientific discovery. It's not just about theoretical brilliance, it's about the interplay between theory, experiment, and imagination.
And in the case of Saturn's rings, his model, based on those tiny particles and their intricate gravitational dance, turned out to be remarkably accurate, later confirmed by observations from spacecraft.
Exactly. It's a beautiful example of how scientific thinking, combined with careful observation and a touch of creativity, can unlock the secrets of the universe, even those that are millions of miles away.
I'm starting to understand why Maxwell is considered such a legend, but I'm curious. Beyond his specific scientific discoveries, what kind of legacy did he leave behind? How did his work influence the course of physics and the scientists who came after him?
Maxwell's impact on science is immeasurable. His work on electromagnetism alone revolutionized our understanding of the fundamental forces of nature.
He basically laid the groundwork for modern physics.
That's right. His equations were a cornerstone in the development of Einstein's theory of special relativity, which further unified electricity, magnetism, and gravity. His work on statistical mechanics paved the way for quantum mechanics, which governs the behavior of matter at the atomic and subatomic levels.
So his work didn't just answer existing questions, it opened up entirely new avenues of inquiry.
Exactly. And beyond the specific discoveries, he exemplified a certain approach to scientific inquiry. Rigorous, creative, and always seeking deeper understanding. He wasn't afraid to challenge established ideas, to delve into the complexities of the natural world, and to use both mathematics and imagination to uncover its secrets.
It's like he embodied this spirit of intellectual curiosity and a willingness to push the boundaries of knowledge.
Absolutely. And that spirit continues to inspire scientists today. He showed us that the universe is full of mysteries waiting to be unraveled, and that through careful observation, rigorous analysis, and a touch of creative thinking, we can begin to understand those mysteries.
It's incredible to think about how his work, conducted over a century ago, continues to shape the scientific landscape even today. But there's another aspect of his legacy that I find particularly compelling: his humility and genuine warmth, which shine through in his letters and the accounts of those who knew him.
You're right. Despite his extraordinary intellect, he wasn't arrogant or aloof. He was known for his kindness, his sense of humor, and his deep faith, which permeated every aspect of his life.
It's like he had this remarkable ability to connect with people on a personal level, regardless of their intellectual background.
He was a true gentleman, driven by a sincere desire to understand the world and to use his knowledge for the betterment of humanity. And I think that's an important takeaway from our deep dive. James Clerk Maxwell was not just a brilliant scientist, he was a remarkable human being who embodied the best qualities of intellectual curiosity, scientific rigor, and genuine compassion.
I couldn't agree more. It's truly inspiring to see those qualities woven together in such a remarkable individual. But sadly, his life was cut short.
Yeah.
He died at the young age of 48,
Ugh.
which is heartbreaking considering all the potential he still had.
It is a tragedy, but what's even more remarkable is how much he accomplished in such a short time. His contributions to physics, mathematics, and engineering are vast, and have had a lasting impact on our understanding of the world.
It's like he crammed a lifetime's worth of work into just a few decades.
And despite his untimely passing, his legacy lives on. The Maxwell Institute for Mathematical Sciences at the University of Edinburgh, named in his honor, is a world-leading center for research in mathematics and its applications. It's a fitting tribute to a man who made such profound contributions to both fields.
It's incredible to think about how his work continues to inspire and challenge mathematicians and scientists even today. But beyond the institutions and the equations, there's something else about Maxwell that I find deeply resonant. It's the sense of wonder and awe that he brought to his scientific pursuits.
You're right, he wasn't just trying to solve equations, he was trying to understand the very fabric of reality, to unravel the mysteries of the universe. And in doing so, he showed us the beauty and elegance that lie at the heart of physics.
And that sense of wonder, that appreciation for the beauty of the natural world, is something we can all carry with us, whether we're scientists or not.
Absolutely. It's a reminder that the universe is full of wonder, and that there's always more to discover, more to learn, more to understand.
And that brings us to the end of our deep dive into the life and work of James Clerk Maxwell.
It's been a privilege to explore the life of such an extraordinary individual.
I couldn't agree more. I feel like I've gained a whole new appreciation for not just his scientific genius, but also his remarkable humanity. But before we say goodbye, I'd love to hear your final thoughts on what makes Maxwell such an enduring figure, someone whose work and life continue to resonate so strongly even today.
Well, I think it's the combination of his brilliance, his humility, and his deep sense of wonder. He was a man who could grapple with the most complex scientific concepts while maintaining a sense of awe and appreciation for the beauty of the universe. He was driven by a genuine desire to understand the world around him and to use his knowledge to make it a better place. And I think that's a legacy worth celebrating.
Beautifully said. And to our listener, we leave you with this. What aspect of Maxwell's life or work resonated most with you? What spark of curiosity did he ignite in your own mind? We encourage you to continue exploring, to delve deeper into the mysteries of the universe, and to never lose that sense of wonder that Maxwell so beautifully embodied.
Remember, the world is full of wonders waiting to be discovered. Who knows? Maybe you'll be the next Maxwell, making groundbreaking discoveries that change the course of history.
Until next time, keep diving deep.
It's amazing to think about how Maxwell's legacy extends far beyond just his scientific contributions.
Yeah.
He was such a complex individual, deeply engaged with the world around him, both intellectually and spiritually.
It's true. One of the aspects of his life that I find most fascinating is this seamless integration of his scientific pursuits and his religious faith. It's something that often gets overlooked, in the textbooks.
Right. You often hear about this perceived conflict between science and religion, but Maxwell just seems to have effortlessly navigated those two worlds. Exactly. For Maxwell, there was no contradiction between his scientific work and his belief in God. He didn't see science as undermining his faith. Rather, he saw it as a way to further appreciate the beauty and the complexity of creation.
And this wasn't just some private belief that he kept to himself. He actually wrote extensively about it in his letters, didn't he?
He did. His letters are full of insightful reflections on his interpretations of Scripture and his exploration of the relationship between reason and faith. He delved into the works of philosophers like Kant and Mill, searching for a framework that could reconcile his scientific understanding with his spiritual beliefs.
It's clear that this wasn't just some superficial belief for him.
No.
He was genuinely grappling with these big questions, seeking a deeper understanding of both the physical and the spiritual realms.
He was. And what's striking is that he never seemed to feel the need to choose between science and faith.
Right.
He embraced both, recognizing that they offered different but complementary ways of understanding the world.
I think that's a really important point, especially in today's world, where there's often this pressure to pick a side. Maxwell shows us that it's possible to embrace both scientific inquiry and religious belief.
Yeah.
These two ways of knowing can actually enrich and inform each other.
Absolutely. And beyond his intellectual explorations, his faith seems to have infused his personal life with a deep sense of humility and compassion.
You can definitely sense that in the way he interacted with his students and colleagues. He wasn't just brilliant. He was also kind, generous, and genuinely interested in the well-being of others.
And that warmth and humanity shine through in his writings as well. His descriptions of scientific phenomena are often filled with poetic imagery and metaphors, revealing a mind that was not just analytical, but also deeply creative and imaginative. He saw the world through a lens that combined scientific rigor with artistic sensibility.
That's a beautiful way to put it. It's like he could see the poetry in physics, the art in equations. And I think that's what makes him such a compelling figure, someone who transcends the stereotype of the cold, calculating scientist.
Right. He was a complete human being, embracing both his intellectual and his spiritual side, his scientific curiosity and his artistic sensibility. And that wholeness, that integration of different ways of knowing and experiencing the world is something we can all learn from.
Maxwell's life is a testament to the power of embracing our full selves, of recognizing that there are multiple ways of understanding the world, and that true knowledge often lies at the intersection of different disciplines and perspectives.
He reminds us that it's okay to be both a scientist and a person of faith, a logician and a poet, a thinker and a feeler, and that by embracing this multifaceted nature of our being, we can live richer, more meaningful lives.
Well, I have to say, this deep dive has been a real eye-opener. James Clerk Maxwell was so much more than just a name in a physics textbook. He was a visionary, a poet, a man of deep faith, and one of the most brilliant minds of his time.
He truly was a remarkable individual, someone whose life and work continue to inspire and challenge us today.
And to our listener, we hope this deep dive has sparked your own curiosity about Maxwell and his incredible contributions to science and humanity. We encourage you to delve deeper into his life and work, to explore the connections he made between seemingly disparate fields, and to never lose sight of the wonder and beauty that lie at the heart of the universe.
Remember, the world is full of mysteries waiting to be uncovered. Who knows, maybe you'll be the next Maxwell, making groundbreaking discoveries that change the course of history.
Until next time, keep diving deep.